So far, you guys have learned one way to solve a quadratic equation. So, if you had x squared plus 3x plus 2, you guys learned how to solve it by factoring and setting your factors equal to 0. So, there is another way you guys can solve quadratic equations, and that's by using the square roots. A number r is the square root of a number s if that number r squared equals that value s. So, 3 would be the square root of 9. The square root of 9 equals 3. So the radical is the entire thing. So if we have this square root of 14, the radical is the square root and the number inside there. The radical sign is just the root, and the radicand is what's underneath the radical. So we're going to learn how to solve these by using just the square root, or taking the square root of a value. So there's a couple of things you guys need to remember about square roots and a couple of rules when you're multiplying and dividing square roots. We talked about some of these in that last unit when we were simplifying them, so it should look familiar. It says the product property. If you have a times b underneath that radical, then you can essentially break that up and write it underneath two radicals. The same thing with dividing. If you have it underneath one radical, you can write them separately underneath two different radicals, but in the same fraction. So, for example, if you had 18 and 18, square root of 18, you could break that up into 9 and 2, and that's what we did last chapter when we were simplifying them. Same thing with 2 over 25. You could take the square root of 2 and the square root of 25 separately and get just the square root of 2 over 5, because 5 is the square root of 25. And that would be simplified because you have no radical in the denominator. So example number 1, 2, and 3. One is, they're actually just like what you guys did last chapter. So go ahead and try number 1. You guys need to break down that 80 and find your pairs and find what's left over and simplify that. 2, same thing that we did. Again, these should all be familiar to you guys. Multiply the outsides, multiply the insides. Technically, it's just 1 times 1 on the outside, but on the inside, you get 6 times 21, which is 126, and then you guys need to break that down. So if you're ever stuck, guys, just start with what you started with. If you started with 6 and 21, then that's what you can start with here. 7 and 3, 2 and 3. So we have a pair of 3s and a 2 and 7 left over. So this will end up being a 3 on the outside and 14 on the inside, because it's 2 times 7. And then number 3, square root of 7 over the square root of 16. What is the square root of 16? 4. You can't break down the square root of 7 any farther. It's just 7 and 1. So that would actually be your final answer. So go ahead and try number 1. I'm going to keep moving on here. And we're going to talk about rationalizing denominators, which you guys did do when it was just a single number, but you guys haven't done it when it's something being added or subtracted to something else in that denominator. So let's look at number 4 in your notes, and that's the square root of 5 over 2. Again, you guys can break this up into the square root of 5 over the square root of 2. Now, these are the ones that you guys should remember how to do and that you have done in the past. This is where we're trying to get rid of that radical in the bottom, so we have to make it a pair, make it a perfect square. So to do that, we say, okay, if we multiply this top and bottom by square root 2, because that's what's in the bottom, 2 and 2 is going to make that 4, and the square root of 4 is just 2. On the top, you have the square root 5 times 2, which is 10. You can't break 10 down any further. You could do 5 and 2, but there's nothing that's a pair. There's no perfect squares inside there. So you're just left with the square root of 10 over 2. So number 4, or number 5 is going to be just like that one, guys. Go ahead and try number 5. I'm going to do number 7. So number 7, it says 3 divided by 7 plus the square root of 2. Alright, so this is where you guys have never actually added or subtracted anything on the bottom. You just had one number by itself. So now that we have two terms, we have to figure out, okay, how can we get rid of that radical? Because now it's just not a matter of multiplying by the number that's down there to make a pair. So what you guys have to do is multiply by the conjugate. So the conjugate of 7 plus the square root of 2 is going to be 7 minus the square root of 2. The 7 stays, the square root of 2 stays. Your sign just changes from a plus to a minus. So multiply the top and bottom by 7 square root 2. So we have to distribute. So 3 times both of those, so 3 times 7 is 21. And 3 times the square root of 2 is 3 square root 2. Now on the bottom, you guys would have to essentially FOIL this, but if we do that, so let me just do it down here in the bottom. So if we do 7 minus square root 2 times 7 plus square root 2, what happens is you get 7 times 7 and then negative 7 square root 2 plus 7 square root 2 and then minus 2 times 2 is square root 4. So this minus and plus actually cancel out. So what happens when you multiply by conjugates, guys, is that you're essentially only having to multiply the first term and the last terms together. So 7 times 7 is 49, and negative times a positive square root 2 is a negative square root 4. So what is the square root of 4? Just 2. So 21 minus 3 square root 2 over, this becomes 49 minus 2. So 47. The last step you guys have to do is just, I call it the heart check, because you have to check these three terms, the 21, the 3, and the 47, and make sure that there's no number that can divide into all three of them, because if there is, that means you need to reduce. And I'm looking at that, and I know that 47, there's not much that goes in there besides 47 and 1. So there's nothing that needs to be reduced here. So this is going to be your final answer. So this is rationalized. Your denominator has no more square roots in it, and you can't reduce any further. So that would be number 7 completed. So number 6 is going to be just like it. You'll just have to say, okay. Oh, and I did number 6 instead of number 7. So let's fix that. So this is number 6. So number 7 will be just like that. So you guys will just have to figure out, okay, what would the conjugate be of 5 minus the square root of 2? And as examples, guys, let me give you a list of a given expression and then what its conjugate would be. So, you guys are trying number 1, 5, and 7, but let me show you what a list of conjugates would look like. So, say you were given, and actually let's say, given the conjugate. So say you were given 3 plus the square root of 2. Your conjugate would be 3 minus the square root of 2. What if you had negative 6 minus the square root of 5? Your conjugate would be negative 6 plus the square root of 5. The only thing that changes, guys, is the sign. The number values stay the same. You still have negative 6. You still have the square root of 5. The only thing that's changing is the operation. So say you had negative 3 plus the square root of 3. You still have the negative 3. You still have the square root of 3. But the conjugate that would make that rational for your denominator, rationalize it, would be a minus. Say you had 7 plus square root of 2. Conjugate would be 7 minus the square root of 2. The only thing that changes is that sign in between. Then when you guys go to multiply, your middle terms will cancel. That's the idea. So let's flip over our notes. Again, if you want to write that down somewhere as an example, that's fine. Let's flip over and do some examples on the next page.